So who are you? What's your role and where do you work?
I'm Andrew Hillier. I'm the CTO and one of the co-founders of Densify.
When automating resource optimization, a common philosophy is to scale up resources aggressively to ensure performance, quote unquote, fast up, but scale them down cautiously over a longer time horizon, which would be slow down. Do you agree with this philosophy? What data and guardrails are essential before you would trust an automated system to downsize a critical production workload?
So I totally agree with that philosophy because I think if you see something to start for resources, you do want to give it more resources rapidly, especially limits. So you can view requests and limits a bit separately here. You can probably get by with a request not being high enough as long as your nodes have enough capacity. But the limits will kill you if they're not high enough. So you want to get them up quickly. If you see workloads getting ramped up or you're the high water mark, go for that. Down is a completely different question. So we've seen cases where you bring them down because something wasn't busy for a day or two or a week, but it gets busy every month or it's quarter end workload. And a lot of our customers with critical workloads, they have some long cycles and you want to especially keep the limits up. You don't want to be fast bringing the limits down. You want to say, well, even if it's only once a quarter, it needs that much capacity. Leave the limit high. It doesn't cost you anything to have a high limit. It's just a safety net to make sure you have enough resources. So, our view is get a lot of data and learn the patterns of it and really understand the cycles before you downsize things. Because if you're caught with them too small, you'll just get that memory killed. We see if you downsize too aggressively and then it gets busy again, then there's throttling, there's kills, and it's just a mess. So I totally prescribe to that philosophy.
The Vertical Pod Autoscaler, or VPA, is designed to automate right-sizing, yet many teams report challenges with it in production. In your experience, what are the primary limitations that prevent wider adoption of VPA? And are there specific narrow use cases where it truly excels?
So yeah, we've seen that as well. I mean, in our customers that have tried it, where I think the challenge is there's a couple of things. It's using only short-term data. So I think he's looking at a week of a metric server data. So when it downsizes things, it's doing it too quickly. Like it hasn't seen enough data to really know if it can safely downsize things. And so we've seen it downsize things too aggressively. And then when those things get busy, again, you get out of memory kills off that. It seems to generate quite a few of them in some environments. And the other related part of that is that it only supports a fixed ratio between the request and the limit. And so that's very restrictive. You can do guaranteed QoS with it, but anything in between, it doesn't have the ability to set a high limit and a lower request, which is what we find is absolutely necessary for most workloads, where they might peak once in a while very high. The majority of their time is very low. So if you have a fixed ratio between the requests and limits, you're never really going to optimize it very well. And then the other result of what I mentioned earlier is that when they do go down, you'll hit the limit when you increase. Because to bring the request down, you have to bring the limit down as well. So it's kind of a twofold thing. So I find it's for a basic use case. It's good at making things bigger, when they need to get bigger. And if you don't mind the thing getting killed in the process, it can do that use case, but we find it's not really good for saving money because it's not safe enough to really downsize things, looking at the right history and being cautious enough with the downsizing.
Node autoscalers like Karpenter are excellent at efficiently packing workloads based on their requests. However, this can create risk if the workload requests are inaccurate, as Karpenter may consolidate pods onto nodes that are too small for their actual usage during a traffic spike. How do you approach this garbage in, garbage out problem, where the node layer is perfectly optimizing for flawed workload definitions?
Yeah, it's a great point. And so Karpenter, even when you're running on scale groups or scale sets, it's the same thing. If your requests are wrong, if they're way too high, then you're just going to run on too many nodes. And Kubernetes is forced to run more nodes to meet all the requests. So Karpenter is no exception. So it doesn't magically run on fewer nodes. If you're asking for a lot of CPUs or a lot of memory, it'll run them all. Now, if you start bringing those requests down, Karpenter won't nicely consolidate. It's a feature of Karpenter that it'll do consolidation. And so it's really nice working with our product and Karpenter because as you bring down the requests, the nodes consolidate and they go down. Now, you don't want to go too far down. You want to look at the historical patterns of these things to make sure that you're not bringing it way down to just what it's been doing in the last 10 minutes, because when it's busy again, you're stuck on the wrong node and you'll have to go to a different node. So you want to make sure that you're looking at enough data to make sure you get to the right point where you're still accounting for what the thing might grow to, and we've heard this in customers where they have a workload that is not busy for some period of time. It gets scheduled in a tiny Karpenter node. And then when it gets busy, it's stuck and there's nothing you can do. It throttles or it gets out of memory killed and it has to reschedule. So I think that's just another argument to make sure you're getting the requests and limits right based on the historical data and not being too aggressive downward and not being too aggressive upward, but kind of find that right zone so it all works properly when it goes to scale. Kubernetes
turned 10 last year. What should we expect in the next 10 years?
Oh, that's a great question. I think it's becoming core. We see it goes through different adoption cycles in different customers, but it's pretty much everywhere now and it's become pretty mature now. And I think customers are just going to look to have it be easier to manage, right? I think in the early days of any technology, you can have rocket scientists setting it up and understanding it and making it work. But more and more, I think we're going to want to just see it properly self-managed, if that makes sense. And we think we're part of that, and there's lots of vendors that are part of that. So when you bring together the ecosystem, you can stand it up and it just runs nicely on its own, and it manages, and it's intuitive to manage. And you don't have to have a PhD in Kubernetes to understand how to manage it. So I think that's where it's going. And I think, again, there's a lot of vendors on the floor here that are contributing to that, and it'll all come together eventually over the coming years.
How can people get in touch with you?
Well, the best way is on our website, densify.com. If you go there, there's a lot of information on our different use cases. There's a chat agent that will contact you right then if you want to, and you can spin up a trial. And of course, it has the ways to reach us, so that we can be reached quite easily through our website.